Hi, again, I'm Chuck Ingram with Slurry Pavers, and welcome you back to the Slurry Surfacing certification. We're going to be covering in this module Chapter 6 in your manual, and we're going to be talking about problem solving. All right, we've gone from determining just what this slurry surfacing stuff is to what goes into the recipe to make it, to how are we going to haul it and get it to a job site, to putting it in this equipment and putting it on the road. Now some things might go wrong. You know, just Murphy's Law, something's going to happen that is going to cause us to get into some diagnosing of what happened and how do we go about making it right. It's inevitable, it's going to happen, but course of life, that's what's going to happen. So in this module, we're going to talk about how to avoid problems in production and laydown with some proper training and planning. You know, whether it's this type of training or whether it's contractors working in-house, we all have a lot of turnover, and there's a lot of new training that goes on, and there's nothing wrong with continuous training. There's always something that we can always get better at. And simply by getting on a job and coming up with a proper plan of attack and having that plan in place and implementing the plan in itself is going to help avoid some inevitable problems that are going to happen. But it's okay, something's going to happen, so we got to be able to recognize what's going on with that surface mat and identify what caused it. If there's something wrong, what could have possibly caused it? Figure that out, and now we're going to determine the course of action, how we're going to fix it. And these next, I don't know, 3 or 4 slides are probably not in your book, but it's just some things that really need to be paid attention to in the course of project planning and ongoing inspection. But the inspector, whether it's a VDOT employee or the consultant, has got a critical role in the success of a project. Over the years, industry and agency have partnered and come up with a great set of specifications. You got good specs in place, enforce them. You know, the quality of the end job is only going to be as good as keeping an eye out what's going on and enforcing what specifications are there. An improperly applied or improperly constructed, for that matter, job is going to fail sooner and increase maintenance and end user costs. I'm a big proponent of the contractor having to self-inspect himself. Industry folks are the ones that live this every day. We should be in tune with what we're supplying the agency and be able to guide them in some inspection techniques if nothing else. And as you've read and as it's been pointed out, at least one person from the contractor side and the inspector must be VDOT certified slurry surfacing technicians. That's what we're doing here today, is getting everybody approved to take part in the schedules that VDOT has. As is the case with any relationship on any type of construction job or business venture, there's going to be issues that come up. The lower level of resolution that we can come to, the better off we're going to be. So minor problems in the field, deal with them in the field, and just don't let them get any bigger than that. Characteristics of an inspector, but I would argue that the contractor needs to possess some of these qualities as well, all of them. Have a knowledge of what's being inspected, familiar with all facets of the job. Be in tune with what specifications or special copied notes are pertinent to a schedule that you get assigned to. Specs are good guidelines, and within the framework of those specs, sometimes there's just going to need a measure of common sense to take place in not bending or breaking specifications and not wandering outside of the scope of the project, but just be realistic about what's going on out there and act accordingly. Take a look and have good observational skills. You can only act on what you see. Pay attention to the job. You know, it's easy to wander, let your mind wander, not pay attention to detail, but we on the industry side try to stress to our folks to pay attention to what's going on around you. You know, we all hear anymore about the see something, say something. And the same thing goes and applies in the field with this. be courteous, you know, whether it's to one another or certainly our traveling public and our constituents that we're doing work for in their neighborhoods. I try to be mindful that in a lot of these residential areas in particular, the road in front of everybody's house is the most important piece of road in the world. And it's unfortunately sometimes it's their playground, but it's certainly where they live and work every day. And they're going to be mindful of what you're doing. So keep that in mind and be courteous when we're working with the field. It's going to be the responsibility, and again, I think any responsibility of an inspector is the responsibility of a contractor. Be sure your mix samples are taken regularly to check for the asphalt content. In your book, spells it out pretty quickly or clearly just what that frequency is going to be. For instance, with microsurfacing, about every 500 tons of material placed, there should be a sample taken from the application equipment. Initially on a slurry seal job, every 25,000 square yards of production, until we're getting consistent results from those lab tests, then you can probably, on contracts that are big enough, you can stretch that frequency on slurry seal sampling up to 50,000 square yards. A cone consistency test is something that's specific to slurry seal applications only, and it's not required in all districts, although I think it's a good indicator for a contractor that you could even use independently to check out the flowability, if you will, the consistency of a slurry seal treatment. It's a quick test to see how moisture contents in stockpiles will vary from day to day. It could be a quick early indicator on calibration of the equipment maybe being just a little bit out of whack. But again, the cone consistency test is not widely required, but it's a good tool to have at your disposal. And it's only on a slurry seal job. Construction phase, okay, now we've gotten past the stockpile, we're getting ready to go to work. Check your traffic control setup. Make sure it's set up according to the manuals. Pavement surfaces clean prior to the surfacing. Typically that pavement cleaning is going to have to be done once a lane closure is put in place. During that same lane closure and subsequent to any surfaces being cleaned, cover up all your manholes and drop inlets and valves and water valves. We don't want to get them covered with slurry seal. The emergency services people would love to be able to locate their appurtenances when an emergency happens in the middle of the night. Check your weather. All these applications are very weather sensitive. Be aware of what weather fronts are coming and what tendencies it might have to affect what you're doing. Make sure all your materials and delivery tickets are available. And we talked about installing a roof and paper at the intersections if needed. That makes for a nice, neat line. Monitor the application rates and surface texture. Again, we talked about the equipment that's being used out there right now has onboard diagnostics that will, at a moment's notice, be able to supply the inspector and or the contractor for that matter and keep them current on application rates. Are we staying within the specifications? It's a good idea at the end of every day to double check with one another and be sure of verifying the quantities of materials that have been placed. Makes for a whole lot easier to be quantities to reconcile when it comes time for estimate time. Once you get started, longitudinal joints. Use proper spreader box width. Try to place lane or the pavement widths of your slurry surfacing material on lane lines if possible. There's going to be oddball widths on pavements, whether it's in a neighborhood or on a secondary road somewhere. We're going to have varied widths from one end of the job to the other. You might have to use partial width passes and not utilize a full width spreader box at some times, but minimize the use of those half and partial width passes if you can. Transverse joints, you can construct a butt joint with them, but the transition has got to be smooth. Minimize the handwork at the time when you're creating these transverse joints. And if a really good idea to ensure a nice sharp line and good startup point is to utilize that roofing felt again for your transverse joints, either at the end of a pull or at the first part of a pull-off. Start to be able to recognize some problems. What caused them? How do you fix them? Okay, we're going to start off with non-uniform appearance on the mat. Is it discolored? Is it different surface textures? There's a lot of things that can cause the slurry surfacing material to take on a different variation of colors, if you will. We'll talk about that in a minute. There's going to be some surface raveling to deal with. Is it within expectations or is it excessive? What's causing some bleeding or fat spots? And if you have a bleeding section of road that you're, with some excess surface oils that you're getting ready to put some slurry surfacing material on them, how do you deal with that? Why do you have rough areas from poor handwork? What caused it? How do you get away from that? What's causing the tire marks and excessive scuffing? We kind of discussed that in the previous chapter, but we'll see it and see how to cope with it here in a few minutes. All right, let's start with the non-uniform appearance. What can cause one side of a road to look different than the other? What can cause one lane to look different from the adjoining lane? Is the equipment calibrated correctly? Are we using a bunch of truck-mounted pavers on a particular project, and truck 1 is not looking the same as truck 3 in the finished product? What's causing that? Is it the effect of the mineral fillers, the hydrated lime, or the Portland cement that we're adding to the mixture? What does a discolored surface look like with regard to the mineral filler being flushed to the surface? A cool application temperature. Again, we have a wide range of application temperatures that are acceptable, and it's not uncommon in the springtime and in the fall of the year for slurry surfacing materials to not dry jet black initially. Even if everything is calibrated properly and all the mixes are being applied properly, there could be a tendency for that material to dry a brown or even a gray color instead of that initial black. Typically that'll just take some time with daytime temperatures regulating and some consistent traffic. It's just a matter of the curing process being slowed down during the cooler temperatures, and we'll see some pictures of that. There's some mechanical issues that cause discoloration. A pump malfunction, not delivering enough emulsion to the final mix. Stone belt might not have had a full measure of stone being delivered to the mixing chamber. Some of the emulsion feed lines could be clogged with some materials that had set up in the transport tankers. We'll address and take a look at some pictures on each of these and try to determine what caused them. All right, picture there on your left. You can see almost 3 distinct colors on the surface and textures as well. I happen to be familiar with that particular job. It's a dead-end road down the hill in front of you there. So there's not any more traffic that goes in than comes out. There's a county maintenance yard at the bottom of the hill. But the same amount of trucks that go to work every morning come out in the afternoon. Whether they're loaded or not won't have any bearing on what's going on in this picture. Again, having knowledge of this particular job, there were 3 different mixing units being used on this job, and you can see the one on the far left-hand side there. We have a nice looking mat going on. The other ones are discolored because the other 2 trucks were not calibrated in sync with the other. So that one was a pretty graphic example of how calibrations can really throw off the final appearance. Unfortunately, what happens is the calibration issues like this don't show up until much later after the road has been accepted, unfortunately, by the buyer agency. The lines have been placed on it, and just a little bit of subsequent traffic will start showing the ill effects of improper calibration. Picture on the right is, it was a slightly cool temperature. You can see we're out in the wide open there. If it's a sunny day, both lanes are getting the sun. Something happens with the right-hand lane. He might have been placed in the afternoon when it was warmer. The left-hand lane there could have been placed in cooler temperatures in the morning and just had not had a full measure of sunlight yet or enough traffic. So just again, having some history and knowing about the performance of that particular project, that was just simply different temperatures at application that in a short amount of time, within a matter of a week's time, both lanes did blend in and match each other in coloration. But be mindful that cooler temperatures can have a result like that. The job on the left, very similar. The lane on the left was placed the night before, and it was probably too cool to be placed in a slurry seal. It dried, and in long term it has performed. Again, I'm familiar with that one as well. But you can see it's even got a white sheen to it. The cement or the hydrated lime in that mix just made it to the surface, and it has not been completely abraded off yet. The water, as it evaporated, brought some of the mineral fillers to the surface, and it's just there until traffic will abrade it off. The lane on the right had just been placed that morning, and it likely looked like the left-hand lane 24 hours later. But going back to that road a few months later, I can assure you that the coloration did eventually blend in. Picture on the right is an example of a mechanical problem. Looks similar to a temperature-related issue, but the picture on the right was one of the first jobs of the season one year. A tanker that had not been put in service yet, had only been used previously in the year before. It had some, as it turned out, had some old material that got clogged up in some of the delivery lines and was transported to the paving equipment. That, all of a sudden we had blockage in the filters and the lines on the paving equipment. So not the proper amount of asphalt was being delivered to that slurry seal. So that was a mechanical issue that caused the discoloration, not an environmental issue. Surface raveling. Now, one thing we need to point out, first of all, is that a certain amount of minor surface raveling is normal and should be expected. Especially on jobs we mentioned earlier about that burlap drag actually rolling over the surface rock and creating a little bit more surface texture than a secondary rubber strike-off would. That mop, if you will, the burlap drag will roll the rock over. It might lead to a little bit additional surface raveling. The course of the rock might also have something to do with the amount of raveling that's going on the surface. But as part of all these jobs, that's going to happen. We know it's going to happen, and there's a programmed surface sweeping that happens within a couple of weeks of completing the application. So the surface raveling is something that's not going to happen and continue to happen and wear down to nothing. It's an initial phase that happens, and we just want to make sure that that initial phase is complete. And sometime within that 2-week time, we're going to have a surface sweeper to come in and remove the surface raveling. Some other things that might cause the surface raveling would be an application rate that was too thin to hold the larger aggregate in the mix. All right, so if you're on a type C microsurfacing job where you're looking for 20 to 24 pounds of mix per square yard, and your operator is only applying 18 pounds of material per square yard, you're still using that same large aggregate, but all of a sudden you don't have enough matrix to hold that larger rock together. So you're trying to put too much rock in too little liquid asphalt. And as a result, there's not going to be enough mat thickness there to hold that rock together. So you might be losing some of that surface rock to a degree that's not acceptable just because you're not placing enough material per square yard. Read the spec and double check your applications. Improper gradation, not enough fines. Sometimes the rock, as it's come from the quarry, even though these gradations are supposedly guaranteed, it's happened from time to time where there's not enough of the 100, minus 100, minus 200 material in the mix, not enough fines to hold the larger rock together. Consequently, some of the larger rock in the mix might roll out. Those cool application temperatures that we saw, discoloration issues, cool application temperatures can also lead to some surface raveling problems. You don't have the warm surface, you don't have the matrix that's susceptible to holding the rock together. You do get a measure of compaction from rolling traffic, especially when it's a little warm. So the cooler temperatures, you're not getting the benefit of compaction from rolling traffic nearly as much as when it's warmer. So that can lead to a little bit of raveling. And you can simply just open the road up to traffic too soon. And if there's enough moisture left in that mat and we haven't given it enough time to fully cure, it can start rolling out some of the surface stone pretty quickly. Picture on the left is unfortunately on an interstate pavement that was placed at night in the early fall. Typically don't like to do night work with the microsurfacing beyond, say, September. Temperatures dipped a bit in the evening, just led to some excessive surface raveling, as you can see on the shoulder right there. The mat, for the most part, stayed together and held traffic, but it was a point of waiting for a warmer forecast to go back and redo that outside lane, or the inside lane rather, to make sure we got proper embedment of the rock. Picture on the right is simply just using the wrong rock in the wrong circumstance. Neighborhood, we've talked about the type A or type B stone being used in residential areas. This was an instance where a type C or the larger rock was used in a low volume area. At an intersection or a radius where I was standing with that picture, there's a lot of surface raveling. The twisting and turning is going to dislodge surface rock anyway if it's a properly mixed or properly designed mix. But this one had excess rock, excess thickness, and it just led to a little bit more surface raveling. Another thing to be mindful that might have had something to do here. We'll talk in a few minutes about lightly broadcasting some fine aggregate across intersections to allow for immediate crossing of traffic. If you're using a type C stone in a low volume area for the application, the light dusting that you're going to be doing is with this type C stone. You're going to be broadcasting additional large rock to the surface. So that can really exacerbate a surface raveling problem if in case that's the fact. Bleeding or fat spots. You supposedly started with a pretty good road and you laid some slurry seal or microsurfacing down, and all of a sudden you made it look like you've got too much asphalt in the mix. The slurry surfacing, as we've discussed earlier, is to be applied at prescribed application rates, and particularly the slurry seal can only go down one rock thick. So if we're trying to place this slurry seal more than one rock thick or at an excessive application rate, keep in mind your application rate for type B stone is 16 pounds of aggregate per square yard. So if we're trying to apply a type B slurry seal to a road and not paying attention to our box setup or the surface of the road necessarily, and we're all of a sudden applying 20 or 22 pounds of type B material to a road, that's too much of the smaller aggregate being placed in too thick of a pass. So what's going to happen is when subsequent traffic hits that, it's going to embed that rock that we need to be sitting on the surface for some sort of surface texture. It's going to embed it and flush the asphalt to the top. So be very careful, very mindful of your application rate. Sometimes if you get too much water in the mix, the water weighs more than asphalt emulsion, so it's going to push the asphalt to the surface and create a flushed surface. If the underlying surface was very rich in asphalt, there's very little that for instance, slurry seal application can do to mask or cover a rich surface treatment, let's say. Let's say a surface treatment had too much asphalt in it to start with. Likely you will have that same bleeding pattern coming through a thin asphalt slurry seal treatment. Excessive overlapping. You know, we go back to the slurry seal being one to be applied at one rock thick, and so if we're overlapping where two passes meet excessively, where in essence we're putting two layers of slurry seal down in the same area and creating an issue where we could be flushing the pavement. Sometimes these bleeding or fat spots might be simply some of the old crack sealer coming through the slurry. That does happen. Sometimes it's problematic depending on the application rate of the crack sealer. But if a crack sealer is properly applied and the slurry surfacing material is properly applied, we may mention here before we finish, but don't be alarmed if there's a shadow effect of some of the crack sealer coming through. There's a difference between a shadow effect coming through and excess thickness of crack sealer being thicker than the slurry pass, but sometimes it can be problematic depending on how much crack sealer was placed. All right, some self-induced fat bleeding surfaces, a couple that weren't just mentioned. On the left-hand side, you know, we go back, we think, and talk about the tack coat that's used for a micro-surfacing application. This was an interstate pavement application, and the tack coat was placed, and the micro-surfacing was placed, and as soon as traffic started riding on the pavement, these flushed places started happening. You know, right away a bell goes off and you see streaking in it. So that's mechanical in nature. Okay, something mechanical caused that excess asphalt to be underneath the surface of the microsurfacing that was placed. Was the road like that to start with? Investigation said no. In this case here, it was an improper application of a tack coat. The distributor wasn't calibrated properly. Operator didn't pay attention to his application rate. The slurry surfacing or the microsurfacing crew did not pay attention to the fact that there was excessive tack coat in place, and microsurfacing was placed on that, and as it cured, it flushed through the surface. In this case, got fortunate with the repair for that particular mess was just another application of microsurfacing over top of what was already there, and that masked everything very well. Another self-induced problem here where we had some flushing on the surface. You can see clearly a startup point where one machine decided to take off. There was a calibration in the added water that the operator didn't pay attention to. In this case here, much too much extra water was pumped into the mixing chamber as that truck-mounted unit took off. You can dial that water, that added water back as you proceed down the middle of the street there, but to start with, you got too much water in the mix and it caused it to flush. And again, the only fix there is to go back over on top of that once that stuff has a chance to dry and simply re-slurry seal that section of road. Another potential problem area with flush pavements that were somewhat self-induced on this one was a minor rutted section of road that slurry seal was specified for. Now, we've talked about slurry seal being placed one rock thick. We've talked about microsurfacing being able to be placed more than one rock thick, but also microsurfacing with the ability to do minor leveling and wheel path rut filling. Job on the left was slightly rutted, but it was specified for slurry seal. Contractor discussed with the agency to try to change the spec over and apply microsurfacing to it. It was decided to go ahead and place the slurry as designed and see what happens. Famous last three words of problems, see what happens. But, okay, so the slurry seal was improperly placed on a minor rutted section of road, and even the best application technique, waiting long enough to open it to traffic, was simply the wrong material placed on the wrong road. You can't expect slurry seal to do any minor leveling. It was identified and okay, we saw what happened, we know what happened, let's go back and fix it. So 3 months later, an application of microsurfacing was placed on the same section of road, and you can see clearly there that it did bridge the wheel path ruts and was in fact what should have been used in the first place. Other types of flushed pavements that can and can't be repaired sometimes by slurry surfacing mixes. On the left-hand side was some hot-in-place surface recycling that was done, and in that process they use a rejuvenating agent that's hard to calibrate in their defense in some sections of road, and so when there's excessive rejuvenation agent used in some of those sections, it will have a tendency to shadow back through whatever surfacing material you put on top of it. In this case, the microsurfacing wasn't thick enough to mask that resurfacing agent. So the simple fix to that is to put a second coat of microsurfacing on that, which the agency agreed to do. Talked earlier about chip seal surface skin patches and the use of the number 9 rock with asphalt emulsion to do some surface sealing. Again, it's hard to calibrate precisely the right amount of emulsion and the right amount of rock for that type of repair. And in the mid part of the summer and surface temperatures at 135 degrees, the patch that was underneath this section of microsurfacing started coming back to life. And so it's a repair method that I'm not real fond of. Again, because of the difficulty in calibrating it properly, because it was what was a good microsurfacing job now takes it on the chin because what was done underneath of it wasn't quite right. So just be careful with your surface prep. We've talked about how to do it the right way, and we hate to find out the wrong way this way. And this case here, again, I'm just trying to remember. This one here was a case of a contractor error. Putting too much water in the mix, we talked about that. If you put too much water in the mix, the water weighs more than the asphalt, and so the asphalt gets flushed to the surface. And what made it worse was, in addition to too much water in that mix, a nighttime operation that doesn't allow to fully cure at times anyway. And traffic was opened up during rush hour, and immediately the road started flushing. So again, not a catastrophe. The fix here, again, was just another coat of microsurfacing, but if attention to detail, attention to your spec is paid up front, we can avoid some of these problems. Bottom line is, when you're trying to correct a fat or bleeding or excessive surface asphalt problem with slurry surfacing materials, there's no guarantee that the stuff will fix it. Look at it as an individual situation. Definitely do not use a type A type of aggregate to attempt any of these repairs. The finer a slurry surfacing mix is, the more liquid asphalt needs to go into that stone. So a type 2 or a type 3 is a little bit coarser. There's a little bit less residual asphalt content that goes into the mix. So you have a better of a chance to mask some of these surface bleeding problems with that. And you also have some wiggle room in your mix design and your job mix formula, to play with the lower end of the residual asphalt content in some of these repairs. By design, microsurfacing has a lower residual asphalt content, so if it's possible, I would utilize a microsurfacing to fix these type of fat surfaces. You'll have a better chance of success with the microsurfacing. And you know, if you've got an excessively fat, I keep using that term, but the bleeding surface, it's going to get worse in the hot weather. So if you're going to attempt these repairs, it probably makes sense to try to put the surfacing repair mix down either in the spring or the fall during your cooler temperatures when the surfaces aren't quite as hot. But by all means, you know, as an agency end user, consult with a contractor before even attempting some of this. You know, and again, site by site, some of it works, some of it doesn't. So just be careful before you make a commitment. You know, we talked about simply overlapping a seam too much can lead to excessive asphalt within the same small area, and that's exactly what happened here. It was a weird geometry to that road anyway, and caused some weird overlaps for the contractor. But you know, once it was discovered what was going on, you know, there was a problem. Found out that it was a big overlap, had too much asphalt in the same surface area, and decided that the only way to fix it again was to come in with a second application. Set your seams up on lane lines like we've talked about before, and it was a costly fix, but it is a fix. There's plenty of ways to fix some of these surface problems. We talked a few minutes ago about good handwork technique, bad handwork technique. You know, here we have probably a stiff mix for the ground guys to work with anyway, but the handwork was not good. You can already see that the irregular application rates, different pressures on the squeegee, and go back to the same site, you know, a couple years later, it's not going to get any better. It's going to really magnify and really show just what the workmanship looked like. So be careful with all handwork. Mentioned a few minutes ago, accelerated temperatures. We actually had a superintendent out here with a handgun and shot surface temperatures of 138 degrees while this slurry was being placed. That happened to be on the left-hand side a type A slurry, which is good and smooth, met the expectations for the traveling public. They were happy with that. But again, like I just said, the finer the gradation of stone, the more liquid asphalt you have to put into that mix. So we have a type A slurry going down on 138-degree surface temperature. It's near the softening point of asphalt cement anyway. And then you have people backing out of driveways and twisting and turning, power steering, and a lot of scuffing can happen that way. A lot of those minor scuffs will wear themselves in over time. Some of the worst ones here, the deeper ones in the front bottom left, there's going to be areas we're going to need to be patched. But some of the minor scuffing will take care of itself. We talked about sanding, lightly sanding across intersections to allow for straight crossing traffic. It's just common practice that contractors will have to employ in areas where there's a lot of egress that's necessary. It's good for straight running traffic. It's not going to handle twisting and turning traffic, as you can see the tire mark in that particular mat. And those of you VDOT inspectors out there, I'm going to throw this one yellow truck under the bus on this one. He was the guy that scuffed that up. He was the inspector that happened to make a U-turn to go talk with that constituent down at the end of the block and just spun around in the middle of the area that was sanded to allow for straight running traffic and didn't even realize that he had torn the road up. So we go back to being mindful and being aware of your surroundings. And obviously something slipped through the cracks there. Adhesion to crack sealer, we talked about, that may be being a problem in some cases where a crack sealing contractor will apply that crack sealant too thick to the surface of the pavement. Most instructions for crack repair ahead of a slurry surfacing job will call for the sealant to be flush applied, as flush to the surface as possible to allow for the minimal application thickness of a slurry surfacing material. Again, even at well-designed, well-applied, and properly maintained projects, you're going to see a shadow effect through the use of most rubberized crack sealers on a slurry surfacing job. Again, familiar with this location at the center point of that lane. That was a section of road that probably got snow plowed 75 times in the course of one winter. And that obviously abraded some of the thin application of the microsurfacing and exposed a little more of the rubberized crack sealer than would have normally been visible. But you can see that the sealer was still intact. The microsurfacing still intact. It's more of an aesthetics thing than anything else. That material is designed for cracks probably up to and including about 1 inch wide. There's other sealants that are designed for very wide cracks. Again, expect some of that shadowing in some places. Projects like this, even fiberized modified crack sealants are compatible with slurry surfacing materials. But just it goes back to picking the right fix for the right condition. Problem shooting, problem solving. You've got an operator on the left that couldn't drive a straight line, had no control of the mix. The spreader box was improperly set up. The geometrics of the handwork and how he was going to go about paving that intersection were all out of whack. It was just a top to bottom failure of that particular slurry surfacing crew. Not only have you made a mess of a concrete curb and gutter, you've created a situation where the functionality, the aesthetics, and the whole thing about that particular project is certainly worthy of being redone completely. It goes back to our checklist that we talked about. Get our equipment in good, proper operating condition. Train your crew. Make sure you've got a plan for what you're going to be doing, and just pay close attention to what's going on behind the machine while these jobs are going on. Problems like that easily avoided. We keep seeing this picture here, but the guys did a real good job of protecting the concrete valleys and swales, and you can hand work up against that and not necessarily be quite as careful with the end joint as possible, because you're going to tape it off and peel it up, and you'll end up with a straight line right there. No brainer to making something thin like a slurry surfacing material stick to the pavement. You got to remove anything that's going to cause poor adhesion or debonding in the near future. Vegetation, dirt that may have been tracked out of an intersecting street, or whatever. Loose aggregate, petroleum leaks, even our animal carcasses, believe it or not, that weren't removed and paved over. Just be mindful of what the surface is like. It's not going to be a good job. It's not going to be a performing job if it's not clean and ready to accept these materials. Your construction equipment itself may contaminate the road. You can have a hydraulic leak. We talked in our equipment checklist earlier about checking for all these things. We'll see an example in just a minute of some of this dry stone leakage we described a little while ago. Had a piece of equipment contaminating its own job site. And just don't start work until you know that you've got a clean and dry pavement to start dealing with. Debonding is a problem that can be caused by several different things. One isolated section of this road, actually delaminated twice. This particular, again, I'm familiar with some of these. This project here was microsurfaced twice in the course of about 6 or 8 years. This same curve delaminated both times. There was no way to detect what caused it, but that was the only section of road that it happened to. Possibility of maybe an accident going into that curve, and there was some hydraulic oil that had gotten into the base of the pavement and contaminated it, who knows. Loose aggregate from the slurry application equipment. Vegetation is not an incident here, but once the material is not bonding itself very well, subsequent snow plows hitting that area could maximize the problem. But it goes to show that there's several things that can cause the debonding in a mainline situation like that. Typically it's some contamination, and the sooner it delaminates, the sooner the blame can likely be laid on the contractor. If something fails within, say, 6 months of application, there's some kind of contamination that was not noticed or was caused by the contractor. This is an example of that. We talked about loose aggregate falling from the application equipment itself. Underneath the center of the pulley on the continuous run paver, there was a little bit of the slurry aggregate was being leaked. Hard to detect unless you're walking right by the rear axles and looking under the machine while that's happening. But that's an occurrence that will happen. So be mindful of equipment maintenance. And we talked about checking your side skirt rubbers on that return pulley. Irregular surface texture, drags, tears, or other irregularities. One thing we talked about a minute ago, an application rate too thin for the larger aggregate. You're putting down 16 pounds of material where the spec may call for 20 pounds of material per square yard. You're going to have some drags in that. Oversized aggregate in the mix that didn't get screened out at the staging area. It's a big proponent of screening every bit of stone that comes through, that comes and delivered to the project. Seen times actually where the loader operator himself at the staging area can contaminate the material by simply digging too deep on the surface and bringing up some large rock from the surface of the staging area itself. We've talked about dried and broken material on the spreader box. Just the vibration of that spreader box going down the road can dislodge some of the slurry that's dried up on the surface of that spreader box as the day goes on. Sometimes the existing road texture will it can cause irregular application rates. There'll be patches, a rough surface treatment patch could be placed in one wheel path lane and no patch necessary in the left-hand wheel path lane. The different and varied surface textures can affect the application rate and the final texture that you're looking for. And we go back to not only screening the rock as it's delivered, but the spreader box and those burlap drags or the secondary strike-off drags that we use in microsurfacing. Keep them clean as well. The best laid plan, the cleanest aggregate, the screened aggregate, the beautiful mix that the operator's coming up with can be contaminated simply by not regularly maintaining the spreader box. So keep an eye on all that. Joints and seams. Use a proper spreader box width. Again, some of these neighborhood streets, secondary roads are going to vary in width. A lot of the spreader boxes anymore are hydraulically adjustable, not quite as responsive as adjustable screed on a hot mix paver, but we no longer have to take spreader boxes apart and manually bolt in different size plates for the spreader box. So overlapping excessively should not be the problem that it once was. Try to construct the job with placing joints on existing lane lines as possible. Minimize the partial width passes. Transverse joints, use that as a butt joint if you can, but try to minimize the overlap and make that transition smooth. You're only talking about materials that's 3/16, quarter of an inch thick, but if you pile it on top of each other, you can have a bump in the middle of the road. Be mindful of your startup joints. And I always like the idea of using a roof and felt for nice sharp startup joints, whether it's a startup joint or the end of a pass joint. Proper box width, set up, an easy enough road geometrically here. Contractor chose to use a spreader box for his final pass that was about 1.5 feet too wide. Not only is it unsightly, you can cause water backing up against a high seam, and from a cost perspective, you're utilizing way too much material. That excess material costs weren't built into that job to start with. And just improper use of partial width passes and setting up a spreader box for the proper width on this job. It's just hard to imagine what went through the crew's mind on that particular job there, but there's a better way geometrically to set that up. Take time and plan it and do it right. 4-inch wide duct tape doesn't leave nearly as neat a end joint as a 3 or 4 foot wide piece of roof and felt would do. Just pretty poor workmanship there. Which one of those two would you rather have in front of your house or pay for if you're an agency? Poor transverse joint. Yeah, we talked about that a minute ago. At the end of the pool, use a flat shovel to cut the joint, and then you can start up with a butt joint if you want, or you can cut your flat joint with the flat shovel and use the roofing paper to start off of. But minimize those joints if possible. We'll go back to putting in the right equipment on the right job, and if it means putting a continuous run operation out on a primary road to minimize the joints, that's probably what ought to be done if you've got that option. Edge of pavement lines, straight and clean line along the edge of the pavement or the gutter pan. We talk a lot about slurry seal not being brain surgery, but it's very easy to cut corners and do something short-sighted, and you can make a mess of things pretty easily. But just be mindful of quality workmanship. Set up your spreader boxes properly. So that your consistency of the mix is not being lost to spills, whether it's a runner that's out of adjustment or a side rubber that's worn out. Follow your edge line or center line markings. On roads that's got irregular edges, try to keep as straight a line as possible. We've all been on roads that don't have a curb and gutter to align with, and it's just an edge of pavement that might have some chunks of asphalt missing that weren't patched back. Those are places that, if not paid attention to, those holes in the edge of the road are going to be where slurry can leak onto the shoulder of the road. Would rather have a straight line go along and perhaps even leave some bare sections of pavement rather than spill excessive slurry surfacing mix onto the shoulder. If you need to, install a string line. Operators will hate to have to get to that point, but sometimes if you can't find a way to do a straight line mechanically yourself, inspector may have to ask for a string line to be put in. But at either rate, stop operation until you can exhibit the fact that you can in fact pull a straight line and make an attractive job out of it. There's a section of road that it's just an open section of road, but there is a straight edge line that these guys are following pretty well. You can see from the unpaved lane here, they've got a proper box width set up. They're going to be right about the center of the road, not any excessive overlapping when it comes to pave the right-hand lane. The tack coat had been applied to the end of the project, and he's got a nice piece of roofing felt there to stop him at the end of the pool. So that was a well thought out plan being executed fairly well by a good crew. You get into the confines of a curb and gutter neighborhood, challenges are a little bit more acute, but properly trained crew, properly set up equipment, properly designed mix design, you can go right along the edge of a curb line and not have any excessive waste of material or need to go back and do any cleanup. Just a nice, neat job. Opening to traffic. The weather is going to be a controlling factor on how long it's going to take a lot of these slurry surfacing mixes to cure, even in the fact of the microsurfacing. Now, we'll say by spec we should be traffic ready in an hour. There's times when that's going to wiggle because of ambient conditions, even more so with the slurry seal itself. Contractor has the ability to formulate a mix design to match up with the weather. The labs at the emulsion plants have the opportunity to custom make an emulsion to better suit the climates that they're dealing with on a regular basis. Stick to VDOT specs that outline temperature restrictions in terms of application situations. And if a problem persists, cease the operation until the weather improves or the formulation is changed. There's times when, in the middle of the summertime, we've all seen it happen. We're in the middle of an 85 to 90 degree spell and something happens and we've got a 72 degree high forecast for a couple of days. Well, sometimes that emulsion that's engineered for 95 degrees is not going to be the right emulsion to use on a 72 degree day and vice versa. So keep up with your weather forecasts, work hand in hand with your supplier, and they should be able to custom and tailor make you an emulsion to fit whatever climate that you're faced with. And even on a nice day, you know, some of these slurries just won't dry properly. You know, when you've got a, you know, we go to that 95 degree day when we've got an emulsion that's manufactured to give us that 1 hour return to traffic time for microsurfacing, or we know at 95 degrees this slurry might take an hour or two to cure. Now we get a 70 degree day, and that emulsion that's going to dry properly in hot temperatures on this 70 degree day on the left is going to take quite a lot longer for it to finally be traffic ready. Then there's going to be times when we may pave too late in the day and you simply have to open the lane to traffic, and sometimes you just make the decision to open the lane of traffic a little bit too soon. The day before they time things out properly. This day here, traffic was just turned loose on that road a little bit before it was completely dry. And there may have even been a little bit of minor rutting in that particular lane, but materials are going to dry differently in different situations. The weather could have been a little bit different on day two, who knows. Tire marks and traffic damage, you know, we're going to see it every day. Vehicles are going to enter a lane closure while the slurry or the microsurfacing has not fully cured. Depending on how soon after application, it could be minimal damage. It could be a damage to the point where we're going to have to just identify that spot and go back and repave that entire section of road. Sometimes it's a lane wide for 20 feet. Sometimes it's a lane wide, as we'll see in a minute, for quite a ways. We can broadcast light coat of the sand or the aggregate that we're using at some of the crossing points to allow for immediate crossing traffic. But then you got to be careful with your strategic cone placement to protect that area and delineate traffic and make sure that it's routed over top of those areas that you purposely marked with the block coat. Whenever you do run into a situation where you do have someone that's crossed into a wet lane, it's likely going to set up a situation where a full lane wide repair is needed. Hand patches of irregular widths, they won't be squared up properly, they won't look right. It's always best to do a repair at full lane width. It's much more functional, it looks a lot better. Sometimes the marks that crossing traffic will make may or may not go all the way through the pavement. But when you do have tire marks that go across a wet piece of slurry surfacing material, patch it with a full lane repair and make sure that if those tire marks do go through the existing pavement, that you do identify them as a repair. Some of the areas that don't get rutted or torn all the way to the existing surface may not need patching, but be mindful that those marks will likely be there for quite some time. They're not going to completely iron in. The left-hand side is just a return to traffic, maybe a little bit too soon at that radius. You pick the rest of the lane, may have been dry enough, but by the time they got around, this is obviously an older picture. The job had been done the previous year. An instance where likely the material was open to traffic before it was fully cured. The one on the right there is actually, you can see where the delineation of the lane closure, they're funneling traffic onto that side street. There was a black sand that was used for blotting material on that one, and it is virtually impossible, or invisible rather, when you're using that black sand for blotting material, and it does a very, very good job. Doesn't have the large aggregate involved, so it's not a hindrance to crossing traffic. It makes a cleanup 2 weeks later with your sweeping operation a whole lot better as well. Both of these situations, obviously you can tell here, especially the one on the left, it wasn't very clear where traffic was supposed to go. His cones weren't placed very well. We got some damage there that is going to require at least a lane-wide repair. And the one on the right is just, there had to have been some, at least bad confusion on the traveling public part, if not just probable negligence on the traffic control setup. So just be careful of your traffic control setup and be mindful of where people might go. Joint overlaps we talked a little bit about. Both these pictures were taken from the same job, same crew, same machine, and everything. The picture on the left, proper box width was probably selected, but to look a little bit closer, you'll see that the seam is a little bit higher than it ought to be, and it could back up some water. Further on down the road, the crew made an adjustment to the spreader box and laid a really nice looking paving seam. It's nearly impossible. So that it's going to ride right and it's going to drain right. So just be very mindful of what your joint overlaps look like. In a nutshell, it really doesn't matter what type of roadway that is designed or planned for a slurry surfacing material. And we can identify problems, we can identify what's good, but at the end of the day, it doesn't matter what type of roadway that we're working on. Proper planning, proper training of the crew, proper setup of the paving equipment, proper materials that are used, whether it's an interstate pavement, an arterial road, a secondary road, or a residential street, they can all turn out as a successful project, again, with the proper planning and oversight. So with everything taken into consideration, I think we can hope for results like this if everything is just I's dotted and T's crossed. And with that, I believe we're going to wrap up Chapter 6 for problem solving. If you have any further questions right now, certainly it's all in the book that we just covered. There are specifications. We mentioned specifications several times. There's specifications in the glossary section of the manual in the back. You've got a facilitator in the classroom with you. Please ask questions if you have anything. If you'd like to contact me through Slurry Pavers, please do that. I have inspectors that call me all year long. Be glad to address any questions that you may have. And also might be a good time to review your knowledge checks. But I thank you for your time.